According to NASA, dark matter constitutes about 27% of the universe. In fact, dark matter is more than 5 times as abundant as normal matter. Normal matter is what forms the things we can actually observe, and it makes up only about 5% of the universe. The rest of the universe, the remaining 68%, is dark energy, but I'll explain that in another video. For now, let's examine dark matter. Today, scientists aren't completely sure what dark matter is, and it remains an unproved theory for now. However, it has been used by scientists to reason various inexplicable phenomena in our observable universe. In a solar system, such as our own, the vast majority of the system's mass is situated about its center, which, for us, is our sun. With simple Newtonian physics, we can deduce that velocity equals the square root of the gravitational constant multiplied by the mass of the body being orbited over the radial distance. This principle produces a velocity radial distance curve that follows a pattern dubbed the Keplerian decline, because the graph concurs with Kepler's laws. On the other hand, in the case of a galaxy, such as our own Milky Way Galaxy, the appearance of our galaxy shares similarities with our solar system. There seems to be a bright, massive object at the center with many less massive bodies orbiting it. As a result, scientists in the mid-1900s expected a similar Keplerian curve for the velocity of stars. However, when they gathered and plotted actual data of stars in the Milky Way Galaxy, they were surprised to see that the graph, instead of declining, somewhat plateaued out. This curve is called the galaxy rotation curve, a velocity radial distance graph that most galaxies adhere to. Scientists concluded that this anomaly could only be explained by tremendous masses of matter that we could not see, named dark matter, which cause stars to orbit with velocities that do not agree with the speeds of orbiting bodies in a system in which most of the mass is located about the center. Furthermore, they recognized that this invisible matter could be found all over galaxies and is actually more abundant than discernible matter in the universe. Today, we attribute this difference between the observed and expected curves to the existence of dark matter. Yet, even after decades of research, astronomers know very little about this invisible material. Scientists have devised two different inferences for what dark matter could really be. The first is that dark matter is composed of baryonic matter. This kind of matter is the normal matter that we can see, along with machos, massive compact halo objects, which consist of black holes, neutron stars, and red, brown, and white dwarfs. However, because a tremendous amount of dark matter that is thought to exist is very unlikely to exist entirely in the form of baryonic matter, the baryonic matter theory has been widely dismissed. Instead, scientists believe it is more likely that dark matter is composed of non-baryonic matter, which is starkly different from the matter that we are capable of observing. Individuals backing this theory claim that dark matter comprises of new particles which are different from atoms. The most probable candidate for what these particles could really be has been WIMPS, or weakly interacting massive particles. These are heavy subatomic particles that are electromagnetic, which indicates they are invisible. In addition, mathematicians have deduced that if they do in fact exist, WIMPs must be about 5 times as abundant as normal matter, which would be surprisingly accurate considering matter constitutes about 5% of the universe, while dark matter constitutes about 27%. This coincidence has been dubbed the WIMP miracle by scientists. However, even with the promising traits of WIMPs, scientists have recently begun dismissing the theory of WIMPs because of the results produced by colliders and data detection. If you wish to read more about this dismissal, I will provide a link in the video description. Ultimately, even after decades of research, scientists know dark matter must exist to explain the observed velocities of stars in our galaxy, but they have almost no idea for what dark matter could really be. However, that's the beauty of space. We know so little about it, meaning there remains countless discoveries to be made about what really lies outside of Earth. Though scientists have always been unsure of what dark matter is, one thing is for certain. It exists all around us in our Milky Way galaxy, and that is all the more reason to explore.